Assalamualaikum warahmatullahi wabarakatuh. Today, I'll be presenting a paper which entitled Body Mass Index, BMI Effect on Oximeter Reading based on Intra-body Communication, IBC, Home Healthcare Monitoring System. My name is Abdul Hadi Abdul Razak. I'll be your presenter for today's presentation, and the other co-authors of this paper is Muhammad Ashrafuddin, Abdul Karimi, Muhammad Faizul, Fairul Nazmi, and Said Abdul Muttalib. And we are all from Electronic Architecture and Application ERA Research Group from the Faculty of Electrical Engineering, UiTM, University Technology Mara Shah Alam. Okay, basically this is the content of my presentation today. First of all, I will go briefly into the introduction. Then I'll go deeply into the background survey, what is IBC and why we want to pursue this research. Then we explain in detail how we does the methodology to achieve the objectives, and hence we present the result and discuss the discussion, and lastly we conclude the conclusion. So first of all, what is a wireless body area network, or in short, W-band? Okay, it's a wireless communication technology that is optimized for low power consumption and operate in or on around human body to enable a variety of applications including medical, consumer electronics, and personal entertainment. So this is W-band application that I mentioned. We have a fitness monitoring, wearable audio, which is entertainment, and of course the application that we are focusing on, the biomedical application. So basically, in IEEE 802.15.6 standard update, it was first proposed in 2009. The standard was published on 29 of February 2012. So what's the overview of this IEEE standard, the architecture? So we look at the W-band, basically the media access area MAC and security is one part, and they divide it into three parts of physical layer, which is narrow band, ultra wide band, and what we are focusing on is the intra-body communication, physical layer. So what is intra-body communication? Intra-body communication is defined as intra-body communication is a technology using human body as a transmission medium for electrical signal. So the types of intra-body communication, there can be divided into two parts. First, we call it a capacitive coupling, where it uses electrostatic coupling type, and another method is galvanic coupling. It utilizes waveguide type. So what are the advantages of this intra-body communication? First of all, it is consume low power. It requires less power compared to other similar products available in the market, such as Bluetooth, Zigbee, and what's not. And then low path loss, less influence on electromagnetic noise and obstacle on signal transmission because it's going through the human body. And it's secure, highly confidential, and data security, since signal does not transmit through air but absorbed through human body. So if we compare what's available in the market currently, this is yellow part, this is the wireless body area network, and also what we are focusing on, the intra-body communication, which is the IBC standard that is stated there. If we compare to Zigbee, Bluetooth, Wi-Fi, and wireless USB, this is other competition which is using a wireless communication. So it's, of course, the intra-body communication, the data rate is not that high, the speed. But what's the advantages is the average power consumption is very low compared to Zigbee, Bluetooth, Wi-Fi, and wireless USB. So, so if we look in the market, the current standard-based solution optimized for other application, but they modified it, they utilize it to use as a W-band standard. For example, Bluetooth was optimized or designed for voice link, and Zigbee was optimized for industrial sensor, smart grid, and so on, while Wi-Fi is optimized for data network. Wireless USB is optimized for connection of computer peripherals. So all these communication are transmitted airborne. So possible to modify existing standard to support home healthcare monitoring application, but these modifications are just short-term solution. It is possible, but not optimal, or it's not optimized for such application. So existing standard carry significant overhead. They were designed with other application in mind. None of the existing standard meet the peak power consumption requirement. None of the existing standard are optimized for home healthcare monitoring application. So a better choice is if we can design a technology specifically for home healthcare application. This is what we are focusing on, the IBC, which is called intra-body communication. So intra-body communication based home healthcare system is, if you look at this figure, what I can explain is it uses a connection of a network of sensor on body. Okay, remember it's on body, and it's wirelessly connected to a link sensor in the middle. So, and then from that link sensor, it can transmit wirelessly airborne line to hospital access point, patient monitoring, or patient data record. So this only need one part that is wirelessly transmitted to somewhere else, but all throughout the body, which consume low power, they uses intra-body communication links. So for our methodology, we design the transmitter and receiver electrode implement on human body, and then we wear both of the we use both Arduino board at hand. So this is the transmitter and also the receiver of the IBC. Okay, if you look at this, what we design, if you switch, okay, first we switch on. If no, it go to end. If yes, it makes sure that the oximeter sensor are correctly at hand. Okay, and then the oximeter reads the heart rate. If no, it go back to the initialize the oximeter. If yes, the data will transmit to Arduino 2, then received by Arduino Nano 2. This is the transmitter to the receiver. The reading from the oximeter and the accelerometer sensor will be displayed on the OLED screen at that end. So this is the block diagram of our system design. This is on the top part is the transmitter. So with the switch, oximeter, the sensor we use, the oximeter, and also just additional accelerometer just to prove the functionality of our system design. But we are focusing on oximeter as the result. So the Arduino Nano board, this will serve as the brain or the processing part of the transmitter, and we use electrode connected to the first part of the body, and we connected to the other part of the body to where we want to receive it, receive electrode to another microcontroller to process the data, and then we display it on a OLED screen. So basically this is the overview of the prototype. As you can see, the Arduino board 1 is the transmitter, the ground ECG, the power ECG, that's the cable. So it transmits, there's no connection there, it's not airborne, it's transferred through the human skin. This is in this picture it uses galvanic coupling, which is waveguide. So the oximeter sensor is from at the transmitter side, and we have an OLED display at the Arduino board 2, which is the receiver. So this is the transmitter, the side view. We have an accelerometer sensor, the battery, and then the transmitter. So the top view, you can see the transmitter, the accelerometer, and the oximeter sensor at using the thumb. to detect the information, and will be displayed at the OLED screen. Let's see that BPM reading from the oximeter, and the X, Y, and Z axis is from the accelerometer trial axis. So this is the side view, the battery, the receiver, and the OLED screen. So from the reading that we get, it's quite interesting. There's less error that we can detect. We compared 4 different categories of volunteer which is underweight based on the BMI, the normal weight, the overweight, and the obese. So this is the reading from the oximeter reading compared to time, the underweight, normal, overweight, and obese. This is the overall comparison test based on the 4 BMI category: underweight, normal, overweight, and obese. So what we can conclude from the experiment and to test the IBC transceiver that we designed, a wearable intra-body communication transceiver was successfully created and utilized for home healthcare monitoring system. The RF module was rigorously tested for data transmission and the reception using the IBC method. However, okay, this is what our first finding, and the only finding, I think. The limitation were observed on the oximeter performance when tested across various BMI levels of different users. The result indicated that the oximeter faces challenges in accurately measuring the BPM, beats per minute, of overweight or obese user, while the function well for user with normal and underweight BMI levels. Maybe we for future experiment, we need to see why this occur. Maybe from my point of view, mostly because of the maybe the fat or the thickness of the skin that reduces the maybe the attenuation or the losses of the signal from that point of view. But we need to study this further. Okay, for future recommendation to address this issue, to ensure the project suitability for all users of all BMI level, it is recommended to develop an oximeter with higher sensitivity. This is one option. Additionally, employing a low frequency transceiver can help reduce power consumption and minimize the risk of current injection through the human body. So what our main recommendation that is for future IBC designer, it is imperative for designer to consider the user BMI level as a critical factor to enhance measurement accuracy and ensure the effectiveness of healthcare monitoring system using IBC. Okay, with that, I conclude my presentation, and thank you for listening. See you again. Bye. Assalamualaikum.